Today, we are diving into one of the most famous, and let's be honest, one of the absolute weirdest ideas in all of science, Schrödinger's cat. It's this brilliant thought experiment that really makes you question what reality even is.
I mean, how can anything be both dead and alive at the exact same time? It just sounds completely impossible, right? A total contradiction. But, in the bizarre world of quantum mechanics, this is the kind of mind-bending paradox you have to grapple with.
And this isn't just some boring physics problem. At its heart, it's a story. It's a story about a cat, a box, and a fundamental rule of the universe that's just, well, it's really strange.
All right, so let's get right into it. What exactly is this famous thought experiment all about? Let's set the scene.
Okay, so imagine this. You've got a cat, and it's inside a steel box, completely sealed off. Now, inside with the cat is this little contraption. Think of it like a deadly mousetrap. There's a single radioactive atom. If that atom decays, a Geiger counter next to it will click. That click triggers a hammer. The hammer smashes a little glass vial of poison, and, well, you can guess the rest. It's bad news for the cat.
So here's the absolute key. The fate of this big, everyday thing, a cat, is now completely tied to the totally random behavior of a single, tiny subatomic particle. The world we see is chained to the quantum world we don't.
Now, to really understand why this is so mind-bending, we need to talk about the rules of the game down at that microscopic level. And let me tell you, the rules of the quantum world are just different.
So rule number one is something called quantum superposition. It basically says that until you actually look at a quantum particle, it doesn't really exist in one state or another. It exists in all of its possible states at the very same time. It's just this fuzzy cloud of pure potential.
Here's a really simple way to picture it. Think about flipping a coin. While that coin is spinning in the air, what is it? Is it heads? Is it tails? You could say it's kind of both. It's in a superposition of heads and tails. It's only when it lands on the table, when we measure it, that it's forced to become one or the other.
So if we apply that rule to our little box, it means that radioactive atom is in a superposition. Until we check on it, it has simultaneously decayed and not decayed. It's in both states at once. And this, right here, is the core of the paradox. You see where this is going, right? If the atom is both decayed and not decayed, and the cat's life is directly linked to that atom, then what on earth does that mean for the cat?
It leads us to this completely absurd conclusion. If you take the rules of quantum mechanics literally, then the cat is also in a superposition. Before we open the box, the cat is somehow, unbelievably, both 100% alive and 100% dead.
Okay, but hold on. That's not how our world works. We know that. A cat is either alive or it's dead, not both. So what gives? Well, it all comes down to the simple act of looking. This is what physicists call the measurement problem. The moment we observe or measure a quantum system, that whole fuzzy cloud of possibilities, what's called the wave function, it just collapses. It's forced to pick a lane to settle into just one single reality. So let's picture it. We're about to open that steel box. Inside, in that unobserved state, the cat is this ghostly mix of alive and dead. But then, we lift the lid to peek inside. And bam, the second we look, the superposition shatters. The act of our observation forces the system to drop the whole both thing. The fuzziness snaps into crystal clear focus, and reality has to pick a side. And in that instant, the cat becomes one or the other. We'll either find a perfectly living cat or a tragically dead one. The paradox just vanishes. Our very own observation forces one single, normal reality to exist.
The funny thing is, Erwin Schrödinger never actually wanted anyone to do this. He invented this thought experiment to show just how ridiculous it was to apply these quantum rules to big things like cats. It perfectly illustrates this weird, fuzzy line between the bizarre quantum world and the normal, everyday world that we all live in.
So, how in the world do physicists even try to make sense of this? Well, let's check out two of the leading ways people have tried to explain it. Okay, so on one hand, you have the classic view, the Copenhagen interpretation. It basically says when you look, the possibilities just collapse, and only one outcome becomes real in our universe. The other possibilities, they just, poof, gone. But then you've got this other, much wilder idea, the many worlds interpretation. This one says that when you look, reality doesn't collapse, it splits. the entire universe branches into two. In one universe, you open the box and find a living cat, and in another parallel universe, another you opens the box and finds a dead one. Both things happen.
Now, I know this might all sound like some really out there philosophical debate, but here's the thing. This quantum weirdness isn't just a thought experiment anymore. We're actually starting to use it.
So why does this cat story still matter so much? Because that idea, superposition, is the literal engine behind quantum computing. See, a normal computer bit is simple. It's either a 1 or 0. But a quantum bit, or a qubit, can be a 1 times and a 0 at the same time, all thanks to superposition. This lets them chew through calculations at speeds we can't even imagine with today's computers. And this is real. Scientists in labs right now are running experiments with photons and electrons, trying to control these very states.
So, far from being just some weird puzzle, the very same principle that put that poor cat in its impossible state is now being harnessed to build technologies that are going to completely change our world. We're finally learning how to speak the language of the quantum realm.
And that just leaves us with one last kind of dizzying thought. If that many worlds idea is right, it means that every quantum event creates a whole new branch of reality. And if that's true, then somewhere in a parallel universe, a slightly different version of this explanation just wrapped up, and in that one, the cat lived. What if every single possibility isn't just a possibility, but a reality somewhere else?